Hello, everyone. Uh, Thanks for the intro. So welcome to the webinar. So today, as the title says, we are trying to cover how to deploy or start using the state-of-the-art latest healthcare NLP models or the healthcare language models within your own Snowflake environment, and how we tightly integrate and seamlessly integrate these solutions within the Snowflake environment, right? So Johnson Labs is almost 7 years old company specialized in healthcare NLP, and then we are providing services in healthcare NLP mainly, but we are mainly working with the healthcare analytics company and pharmaceutical companies and all the other big stakeholders. So we have what we have been doing and examining so far is healthcare NLP itself. Even before the LLM era, we have been working and shipping more than 2,000 protein model and pipelines to solve certain problems using healthcare NLP. So healthcare NLP is the tool over there that will provide out of the box that you can build your own solutions, own pipeline to solve your own problems. And you can find more information regarding all these solutions and use cases on johnsonolers.com customer use cases. So today I'm going to focus more on how these models can be integrated in the Snowflake environment. But at first, let's see what these models are capable of doing, right? So on the right-hand side right now, you see that we have classic healthcare NLP models, mainly for information extraction or clinical text analysis. So you can extract data, you can extract entities, find the relationship between entities. You can map these entities to certain terminologies, medical terminologies, or you can just build different classifiers or relation extraction model using your own data, using your own annotation within the same infra, because everything is built in one single library we call Healthcare NLP. Healthcare NLP is built on top of Spark NLP itself, so you can just run everything on your on-prem with no cloud access. On the left-hand side, you see our latest medical LLMs and Gen AI products. So we mainly have, just like many other companies, we have healthcare-specific, fine-tuned large language models out there. We named this as by the size of the models, we name it like a MEDS, MEDM, MEDL, etc. And then on top of these models that you can use in Snowflake or in any other environment that you want, we also have some browser-based applications like medical chatbot, which is like you can do you can do literature review on your on-prem by using medical chatbot, which is powered by all these LLMs. And within the medical chatbot, you can also use all these classic healthcare NLP models as a tool, so that you don't need to write any single line of code, because basically you will just be able to tag the model name, and then you will be able to get the results from our models rather than LLM itself. We also have Generative AI Lab, so that you can annotate, you can augment your own data, you can integrate your own models within the and then fine-tune the existing model with the models that you already ship out there, so that you can do better with the data that you have. So long story short, we have more than 2,000 pre-trained models covering multiple dimensions like entity recognition, entity linking, assertion status, relation extraction, data obfuscation, and we have other several out-of-the-box solutions as well. So these are not just we are not just shipping the model right after we train or fine tune. We have our own clinician team and data science team that we also write papers, and then we try to compete with other competitors, and then we try to get some state-of-the-art benchmarks for each model that we have. For the last few years, we have been like for the last 5 years maybe, we published more than 35 academic papers, and then in each one of them we try to explain certain tools that we have. For example, for name identity recognition, we have 5 different papers. For research and studies, we have 2 papers. For LLMs, we have 2 other papers, etc. And then these are all peer-reviewed papers that you can also find on our website. And we write these papers with the other academic and healthcare institutions as well. So apart from the LLM that you see on the upper left corner, those are all fine-tuned for specific healthcare tasks. right? So those are modified versions of model LLM architectures that you can find everywhere, but we fine-tuned them using in-house created medical data set for certain tasks. For example, for summarization, we have another model. For OpenAI question answering, we have another model, so that you don't need to host giant, like 70 billion size of model just to do the summarization or Q&A. Because if you fine-tune small language models on top of the test-specific data set, you would be able to get a comparable accuracy, which I'm going to cover as well. We have out-of-the-box solutions as well, as you see on the bottom right corner. These are like HTC risk adjustment score calculation, medical text-to-speech, text translation, text-to-OMOP, drawing to patient journey. These are all out-of-the-box solutions that you don't need to write any line of code. So we just ship the solution on your infra, and then you start using, or you can just deploy all these solutions in Snowflake environment as well. So if I just go over the healthcare NLP performance metrics, I can just start with comparing ourselves with the other cloud providers like AWS Medical Component, GCP Healthcare API, or Azure Healthcare API as well. And then as you see, when it comes to entity extraction, we are doing less error than the other cloud provider does, and everything that you see on your screen, you can achieve the same on your on-prem without having any API access. Because to be able to use all the other cloud healthcare NLP endpoints, you need to have a private cloud and share your data, right? But in healthcare NLP, you can just deploy everything that you see on the previous presentations on your on-prem or in your Snowflake environment, and then you can just start using it with your own data in an air-gap environment. And as you see, healthcare NLP is doing better than the other cloud providers, and we have a paper for this as well, by the way, in the peer-reviewed section. You can find the details in that paper. So how to compare healthcare NLP versus LLMs, but right? Because LLMs are hype right now that people starting to integrate into their workflow for every use case. But sometimes, most of the times, LLM would be an overkill over there as well, right? So if you want a deterministic solution or small, sizable, scalable solution that could work without costing, without burning so much cloud credit or GPU credits, right? You can just use small healthcare NLP models which are head-to-head with LLMs if you know what you are building over there. Because accuracy-wise, small models can, when they are fine-tuned on created data set, doing better than LLMs sometimes. Speed-wise, of course, this is healthcare NLP is built on top of Spark NLP, which means that you can scale these solutions over millions of documents by using the same license over there. And then everything is transparent because healthcare NLP is you build your own pipeline with the tools that you build over there, and then you can change each block within the pipeline if you don't like the results coming from that stage. Rather than you just send your input and then get your results through LLM, right? You can just control every stage. And then the cost-wise, this is most cost-effective. For all the LLMs out there, if you would like to use them for certain tasks, as I said, you don't need one giant model. You can have small size, like as small as 3 billion or 8 billion size of model that is doing that can be so that can do better than ChatGPT itself sometimes, right? Like I have some benchmarks over there that I'm going to cover, but we ran some large scale analysis over summarization, question answering, closed book questions, and then we see that small language models can do better than GPT-4 size of models on these tasks if you fine tune on certain data sets. And this chart, you see which models can be used for which task. And in this slide, you can see that how to deploy these solutions in different environments. So you can use this on your local, even on your laptop, or you can just use this in your own Snowflake infra with your own data. You can find these models in the different cloud marketplaces, or you can just use this as a cry solution. We don't host anything on our end. Everything that you see here can be shipped into your infra because we don't have a remote API that you can make a call. How these models look like, it's just the same as that you do with any other LLM, right? You send your prompt and then get your answer, but everything happens on your on-prem, and these are all medically fine-tuned models. For example, for summarization, via MEDS, which is less than 3 billion size of model, you get this decent result within a few seconds, which I'm going to show at the end of this webinar. I'm going to show you how you can do the summarization in Snowflake as well. This is madam, we like even 10 billion can be regarded as small right now, right? So madam can be right now regarded like medium size, can be between 40 to 70 billion. But when you go up to that sizes, you can do more complex tasks as well, like not just summarization, but also question answering, especially open-ended question answering without relying on any content. You can even use this as a RAG component, LLM component of a RAG pipeline, right? Retrieval augmented generation pipeline. And then you will be able to ask this open-ended question with no context, and then you will be able to get these results on the right-hand side, right? And you can even extract entities with LLMs. Even if we don't support this idea, because we already have more than 200 different name identity recognition models, but if you have some niche data, niche labels that you are not able to find on our model hub, by the way, if you go to our model hub, you will be able to see all these models. But if you are not able to find what you want, we have a small LLM that can extract structured entities from text data as well, as you see here, so that it returns structured entities without any training, without any fine-tuning. And so what we did is that for the last few months, we have been trying to evaluate our models. So we need some clinical grade evaluation of our LLMs, because we need to show that they are doing comparable, they are doing better or comparable compared to other large LLMs, right? Like a 70 billion size, 400 billion size, or other cloud providers like OpenAI or Anthropic, etc. So what we did is that we generated 400 questions from scratch in 4 categories, like medical summarization, Q&A, biomedical research, and open-ended QA. And then we evaluated in a blind, like we set up some blind trial for 4 physicians for 2 LLMs against GPT-4o. So we pick our MedM and MedL, and then compare these 2 models against GPT-4o across 4 different categories over 3 criteria: factuality, clinical relevance, and conciseness. So this is a randomized blind evaluation, so that the readers didn't even know that which model correspond to which one at which row. So they just ended up with this screen on an Excel sheet, and then they try to evaluate which one is more preferable compared to these 3 criteria: factuality, relevancy, and conciseness. And at the end, for medical summarization, our 8B size of model is preferred 2 times more than GPT-4o itself. Right, so this is amazing actually, because 20% of the time people said that the results are almost same. So compared to this size of model, being preferred more than 2 times compared to GPT-4 itself when it comes to medical summarization factuality, because we know that the clinical text summarization is whole another topic that you may not even know that if the LLM returns hallucinated results. So we focus on these aspects, and then it's great to see that we are preferred more than twice when it comes to GPT-4o, even with 8 billion size of model. In question answering, it is 10% better. When it comes to biomedical research, it is 20 times better. And then open-end, it is almost 5% better when it comes to factuality. And then overall metrics, if I distribute this, like if I distribute the neutral, even on the both side, it's 5% better than GPT-4o itself, like even the 8B model. We are writing a paper right now, which is almost done. We are going to submit to several reputable journals, and then we are going to explain our methodologies them as well as share all our data. So performance-wise, we have one of our flagship product is the identification model, which means that people, like if you want to share your sensitive data, PHI data, other stakeholders, or to do some data analysis with your own data, or just use it for analytic purposes, you don't want to expose sensitive data, right? So that's why we have out of the box the identification and obfuscation logic over there. I'm going to have a live demo at the end of this session. And then compared to GPT itself, we are right now about 95% accuracy on an unseen test set, while GPT itself is around 60% right now. So we have the medical translation benchmarks. Since I'm running out of time, I will just skip some part so that I will talk some out-of-the-box solutions. We are working on a right now patient journey product, which means that the data that you have, including EHR, unstructured tests, FHIR reports, etc., you can build a patient journey using OMOP schema with your own data. We are working on such a solution too that leverages all the products, all the tools that I have been talking so far, because this is not just an LLM solution. LLM is just there as an orchestrator and some reasoning level questions, but the hefty load is handled by healthcare and NLP models that I have been talking so far. So we have text to SQL models as well. We have a paper for this as well. And then the idea is that how you can ask these questions, and then we do this conversion on behalf of rather than writing an SQL query. So I'm going to leave the stage to my colleague, and then he's going to go over what Snowflake offers in terms of implementing these solutions that I've been talking about. And then at the end of his session, I'm going to have some live demo by coding in Snowpark notebooks.
All right, fantastic. Thank you, Veysel. And if you take a look at what Veysel has been going through, I mean, this is where I believe where the AI industry and the technology trends is being headed, right? So we started out with a very large open source model, a very large LLM model, meaning large language models, and then the whole large language model started becoming more and more open source centric. But if you take a look at what's happening in the last 1 year or so, the models are becoming more and more task specific because the performance of a task specific model when it comes to a specific task is far better than a large language model, right? That can basically address a breadth of capabilities. And when we are really talking about a specific task specific model, the ability of that model to be performant for that tasks comes from two different angles. One is, what is that task in itself? For example, Weasel talked about summarization, right? So summarization is a task in itself from an AI perspective, and there are models becoming very tuned for more precision in summarization. And then there is another angle to becoming more task specific, which is giving that industry context, right? So in case of summarizing a generic content that is available in internet versus summarizing a clinical notes, which talks about a lot of clinical jargons, the model then needed to be fine-tuned and trained on the medical embeddings and the clinical embeddings so that that summarization task can perform or can perform well when it comes to the medical summarization as such, right? So with that being said, as our customers are looking to tap into the large language models and its capabilities, the question then becomes, how do we really tap into these type of specialized models, right? How do we bring in a platform that supports all of these capabilities, right? And if you take a look at what Weasel has been talking about in terms of various suite of products that John Snow Lab has, it primarily unlocks insights from three different healthcare perspective, right? In terms of the use cases. Number one is uh, ability to use large language models to leverage it as an assistant per se, right? Answer this question for me, summarize this for me, generate synthetic data, right? I want to give a natural language question and then interact with OMOP, right? So all of these are capabilities that helps assist the healthcare organizations and the corresponding stakeholders to perform what they do in a much more productive way, right? And which has the language context that I was talking about earlier, right? That's use case bucket number one. The use case bucket number two is analyzing the clinical data in itself, right? Named entity extraction, right? Assertions and so on and so forth, which are critical part of unpacking the information and insights from the unstructured clinical data that we see, which is prevalent in healthcare space, right? So that is the second set of use cases that the John Snow Lab models that we still talked about unlocks, right? And it is very important because now we then have um, technology helping us to uncover insights from the traditionally underused data category, which is the unstructured data category within healthcare, and extract that information and put it side by side to the structured patient information, thereby augmenting the patient profile with the 360-degree information of what's really going on from a patient perspective, right? So that is extremely powerful and useful capability. Even the capability that Veysel talked about in terms of using LLM to extract entities. Such a powerful capability, because the moment you are able to extract those information, you are then putting that information side by side to other clinical and claim data of the patients, right? And then the third category that it unlocks is de-identification of sensitive patient data. And this is more aligned towards the research side of the house, where when the data is being shared for clinical and academic medical research, the data needed to be preserved from a patient privacy standpoint, thereby de-identifying sensitive patients' PII and PHI information becomes super critical. And Johnson Labs clinical de-identification models are extremely good in identifying the personally identifiable information within a unstructured document or a medical image, and ability to abstract that information. And that becomes a very important use case when it comes to healthcare research use cases. Okay. Now, with that being said, there are multiple use cases that this type of a model helps from a healthcare and life sciences organization standpoint. And how do we really deploy this type of models on Snowflake, right? If you want to tap into all of these capabilities, you really need a platform that has not only the ability to bring some generic large language models out of the box, but also the flexibility to bring in specialized models like the Johnson Lab models and use it really depending on what use case that you are trying to solve for from using data and AI, right? Now, from that context, these specialized Johnson Labs can be deployed into Snowflake infrastructure from two different design pattern standpoint. Number one is you can take these models that Veysel talked about, containerize them, and deploy it on Snowflake's container infrastructure. So Snowflake's container services is a fully managed container platform that comes with both CPU and GPU based container capabilities. And you can then integrate that model as a container within the workflow that you have or our customers have within their data pipeline environment, right? The approach is that you don't need to take the data that you have within a data platform, push it into another computing clusters. Instead, you bring the model to where the data is, thereby driving efficiency out of this process, right? The other opportunity to deploy this Johnson Lab model is using native apps on Snowflake Marketplace. And Snowflake's native app framework enables our customers to build a packaged function or an application and share that with other customers or the organizations who are using Snowflake. Now, what Johnson Lab has done is they have packaged their offerings, like for example, the healthcare NLP model that Veysel was talking about, as a native application, and that is listed on Snowflake Marketplace. So customers who want to tap into it, they can go to Snowflake Marketplace and click and deploy that particular model into their own Snowflake environment, thereby making this deployment very seamless, right? The difference between the container services based versus native app is one is more I have my own workflow. I really wanted to customize the setup. I already have the license purchased from Johnson Labs. I just needed to deploy it on the container infrastructure, on top of the data that I have. Snowpark Container Services is the best fit in that scenario. But if you are really looking to pay as you go from a compute model perspective, you can just tap into Johnson Lab models available on Snowflake Marketplace and use the native app and pay as you go from a consumption standpoint, right? Now, with that being said, I really wanted to double click a little bit on Johnson Labs deployment architectures 1 and 2 that I was talking about. So in this case, it is the visual NLP, which is Johnson Labs de-identification model. This model helps to identify personally identifiable information on unstructured data, whether we are talking about clinical notes or we are talking about medical imaging, it has ability to identify that and abstract that information. How does this work? You take the visual NLP model and containerize and push the containerized image into Snowflake's container image repository, and then use that as a means to deploy that model as a service on Snowpark container services, and then feed in the necessary images or unstructured content and get that output abstracted and de-identified information, which then be used for various research purposes and many other use cases, right? That's deployment option number one. If you can go to the next slide, please. This deployment number two is essentially tapping into John Snow Lab models on Snowflake Marketplace. Now, if you are a Snowflake customer and you have your data, the patient data, clinical data, medical imaging data, all on Snowflake, you have the ability to go to Snowflake Marketplace and look for the model that is of interest, whether it is clinical NLP model or visual NLP model. You have ability to select the model of interest, and usually and click and deploy. Right now, what happens at that point is that entire functionality and the model gets deployed as a function within your own Snowflake environment, and then you can pass the data that is residing within your own Snowflake environment to use this, right? As I said, the primary difference here is that it is ease of use, ability to click and deploy, and pay as you go model, right? Those are the pros and cons of using one model versus other. But we do provide both integration options so that customers who are in different situations can either tap into this deployment pattern or the other deployment pattern. Okay. Now, with that being said, why John Snow Labs on Snowflake? The benefits is that the number one thing that I was talking about is the flexibility to bring in the most up-to-date SOTA models, on top of the clinical and medical data that you have within Snowflake environments, right? That's a huge capability because that's essentially how you will identify more accurate patient insights and truly drive patient health outcomes, right? Snowpark Container Services from Snowflake standpoint provides a very easy serverless deployment, of any custom NLP pipeline. And then the development interface is very easy to set up and configure it. So defining the container is a very relatively a less effort intensive task. And then the containers and the startup times for these John Snow Labs models are really, really fast when it comes to Snowflake. And then when you tap into the Snowflake marketplace for John Snow Labs models, you have ability to just click configure and deploy and go with the pay for what you use model, right? Now, with that being said, Veysel, I'll hand it over back to you to kind of show something in action. I think you're talking on mute, Veysel.
Thanks, Murali, for a great intro to the Snowflake environment. So as Murali said, you can deploy all these solutions using Snowflake Marketplace in two different ways, like containerized solution or native application. How to find which models are compatible with Snowflake? You can easily go write our website. We have a model hub on John Snow Labs website, like nlp.johnsnowlabs.com. If you go to model hubs and then filter by the marketplace, you will see that right now 15 models are already available, which means they're ready to use in Snowflake environment. And how to deploy these solutions, right? You can deploy with one click on a dashboard, Streamlit dashboard, or provided by Snowflake, because every application that you hear, you can create a demo app, you can create a UI application with by using Streamlit, which is another product of Snowflake, as you know, right? So you can easily build some dashboards and then share with your customers or your colleagues and then experiment further. And then we already ship this kind of Dockerized UI and app or just as an endpoint. Let me show you how you can deploy any NLP model, because if you go to our model hub, right, we have 100,000 different models and pipelines. So when it comes to healthcare, right, if I just filter by the healthcare, we have more than 2,500 models and pipelines over there. And then if you filter by the different marketplaces, you will be able to see all the models that are supported in Snowflake, and you can have the same. For example, you can deploy on Snowflake, Snowpark environment, or even with your like from your own server. As long as you have a Snowflake account and John Snow Labs license, you can deploy any John Snow Labs model or pipeline as easy as this code block. For example, you can create a license model endpoint. For example, this is coming from our model hub because we have these kind of notations. Clinical granular mean that with one line of code, you can extract hundreds of different entities and find the relationship between entities. You can just write the name. This name comes from the model hub that I just showed, right? You can just deploy this by using your own account, like access credentials. When you do this, it's going to be deployed as a UDF, and now you can connect to Snowflake from your own infra and then run it. Of course, there is a better way of doing this, right? This is just if you want to do deploy from from one isolated server and then trigger functions in your Snowflake infra. But let's talk about how to do this on in a Snowpark notebook, right? So since all these applications are already there, like this supported models and pipelines are already there, they are right now basically a UDF, like a user-defined functions that you can run on your own data with your own within your own Snowflake infra. For example, let's get started with the identification, right? Since the identification is one of the applications, one of the models that are already available over there. Imagine you already ship it and then start using it. How to use it with your data to test how it works. I just started my application, and then now I'm going to run this over a sample data, right? Since when you first started this, it's going to take us some time for warm up. Even warm up took like 6 seconds, right? Which means that I just started the application, and then for the first interaction, I just sent some sample text, and then it returned. How does it look like? Maybe I can show, right? So right now I have some data. Let me zoom in. I have some text that contains some PHI information, and then when I just run this, it is just doing the masking right now because we have obfuscation and masking pipelines over there that we return all this. Let me just copy paste and I show maybe how it looks like, right? This is how it looks like, which means that this text is converted into a mask version. So we replace all the sensitive data, we found all the sensitive data and replace with the entity names. You can also obfuscate this. For example, let's obfuscate this. With the obfuscation, we find the entities and replace the sensitive information with the fake entities, like by following some consistent logic, right? So here, let's go paste this and then just to print out in a pretty way. So you see all the sensitive data in the original text is replaced by some other data, some other fake data, by keeping the consistency of the data so that no one would notice this. This is already obfuscated data. So you can run this over some tables, right? If you want to do this over like thousands of records, which is already on your prem within your own Snowflake environment. Imagine this is some data like with some thousands of patient notes. You can just run this UDF on this data, and then there are 100 records over there right now. And then, by the way, when you deploy these solutions, you can configure the compute instances, right? Because you can pick a larger machine, larger instance, and then if you want to control the speed, or if you want to scale the solution further, everything runs on your on-prem, on Snowflake infra. Now this is running over 100 records of sensitive data, which is going to return another table with all the mask and obfuscated results. Okay, so when it is done, you will be able to see the new table. Let's see, because it is running over 100 records, right? I picked a small instance just to showcase. And when I'm done with this, I will be able to stop the instance and then move to another one. You can do the same with the info, like a clinical text analysis. While it is being run, we can just move to another one. This is for explain clinical document, which means that it's going to return the entities, relationships, assertion status, etc. Let's just extract the simple entities from this short text, right? Again, this is going to run at the first time, and then it's going to warm up, and then next time it will be much faster. And let's print out this. I already printed out. As you see from this text, I returned the assertion status with their confidence score, and with the name of the entities as well. In the text, it says that prior heart murmur, right? So it's a past incidence of heart murmur, and then it's a heart disease entity with assertion confidence 1.0. You can just easily go to the NER results. So you see some clinical events, some other entities like disease entities, test entities, data entities, and you can even find the relationship between the entities. Like this entity, this disease, the heart disease entity is related to this test entity because it's the finding of this test. Like echocardiogram's result is turns out that there is a heart murmur over there, which means that there is a positive relationship between these two entities. So you can do the same with another. Let's do this on another maybe mid-sized text, right? Then it's going to return digestible JSON output from this pipeline. This pipeline is the combination of multiple models. As I said, like we have more than 2,000 pre-trained models, right? So we combine multiple models and build a pipeline, and then we call it like explain document clinical, or the identification or oncology pipeline, etc. And then by picking these pipelines, pre-built pipelines, you will be able to run this over your data, and then each one of them is responsible from extracting certain information. If you are doing oncology analysis, you use oncology explain document oncology. If you are using radiology analysis, you can use explain document radiology, etc. You can find all this information in the model app. So as you see, we return all the entities with their corresponding confidence score and entity label, and these are all small size models, which are as small as 15 MB models. So you don't even need an LLM to extract all these entities, right? So if I go back to the identification, as you see, it took like more than a minute to mask 100 patient notes. As you see, everything is already masked, so that you can also obfuscate this, as I showed before. And when I am done, you can just stop the app so that it doesn't incur any cost, or you can just set some timeout so that it's just stopped when you are done. We have, let's move from this and then show another. You can do the same, as I said, if you have some clinical note to process further. Maybe you want to extract radiology or oncology entities outside of millions of records. So you can just read this table from your own DB and then run with the same pipeline. Now, another one is LLM. So LLM is, we have MEDAS, MEDAM, etc. Let's just check our MEDAS. I will just start the app, and then let's warm it up, right? The first triggering is warm it up. It's already there, looks like, which I already run before. So I just ask some open book questions without any, which means that I just give us a short context and then ask a question, which means that it's a open book question, which means that it is answering the question based on the context that I provide. So I provide that like there is a patient with a history of diabetes, and then recently diagnosed with heart disease, and then I ask that, okay, what is the new condition patient recently diagnosed with, and then LLM is able to answer this, which means that with as small as like 2 billion, 3 billion size of model, you can generate these questions beforehand and then run on all your data, like clinical notes. Maybe you are only worried about the patients who have a stage 4 cancer, let's say, stage 4 lung cancer. You can ask this question and then run over millions of records and then find the patients who have this positive diagnosis and then only work with those patient notes afterwards. Or you can summarize this long text into a few sentences, right? So let's run this as well. And as you see, it is running this, like this is just another pipeline, right? And then it is returning this answer in 4 seconds, which means that it is returning this short answer. So let me just read this as a markdown. Right, so the large note converted into a short few sentences, which is, as you see from my, as you can remember from my presentation, when it comes to summarization, mid-size LLMs, just developed by us, Johnson Knowles, is preferred two times more than GPT-4o, which means that you don't need GPT-4 size model to summarize your medical notes because this is already fine-tuned on medical notes. Okay, so we covered 3 different models, like one LLM for summarization or name identity recognition, one the identification so that you can run it on your sensitive data to find the PHI information and mask them and obfuscate them, and explain the clinical document, which means that extract entities, find the relationship, find the assertion status, as well as return ICD-10, Ariston code, SNOMED code as well. So how to find all the available models and how to just start trying, right? If you go to app.snowflake.com and marketplace, like Snowflake Marketplace, and then filter by Johnson Labs, you will be able to see all the available models. Like we have the identification for German, we extract findings in radiology report, clinical identification for Arabic, for Italian, we support 9 different languages, by the way, in the identification. So it's not just English, and we have the benchmark for each one of them. Medical text summarization, extract biomarkers. Maybe you want to extract the biomarkers as well as cancer types, so that you can filter, so you can create some subcohorts to do some analysis, right? You can use these models so that you don't need to deal with millions of records. And then everything happens on your own Snowflake infra without exposing any data. So you can extract adversarial. We have, for example, live demos as well. Okay, so if you want to see how these models looks like before even going to Snowflake, you can even see how they look like. For example, if you go to demo dot like nlp.johnsonalways.com/demos, you can pick any demo here. For example, this is detect entities in clinical notes. Let's see how it looks like. You can just easily pick any model. These are all Streamlit apps. We have thousands of Streamlit demo apps. Streamlit is, owned by Snowflake, as you know, that you can build these kind of dashboards or small applications on your own infra, and then explore the capabilities of the model. So before even deploying anything, you can see what this model return. You can pick other models from the left-hand side and then see how it looks like. Or I can just go to medical terminologies, right? If I want to do some ICD-10 taxonomy, I can just pick different models from here, and then pick another text, and it's going to return the entities and corresponding ICD-10 code. You can extract SNOMED, Resolver, UMLS, ICD-10, CPT, etc. You can extract more than 20 different terminologies within with the same license, by the way. Okay, so coming back to my main point, as you see, we already covered all the available models out there, and I showed how you can deploy the same and then start using. I hope you enjoyed the session. We can also we will be here to answer any question that you might have. I hope you enjoyed the session. Thanks for joining us tonight.
Okay, thank you for that presentation, gentlemen. I do have a couple of questions here for you. The first one is, when John Snow Labs models are deployed on Snowflake, are there any access control/governance controls that can be set?
Yeah, maybe I'll take that question, Veysel, right?
Mm-hmm.
That's the beauty of how you bring these type of models, right? So with Snowflake, you have built-in capability in terms of providing access controls to objects as well as to the data. So for example, if there are folks who does not have access to a certain set of populations, and if they are not allowed to generate insights or extract information from, for example, clinical notes and summarize that for a patient population, you have ability to restrict with the role level data access control policies. Thereby, when you call the function, right, and when you try to really select, and Veysel showed one of the SQLs where he was trying to select from a table and then run a particular John Snow Lab model, it is going to restrict the end users in terms of only allowing it to run on the population on top of which they have access to, right? So the access is something that is built in, right, from within Snowflake. So absolutely, yes.
Thank you. The next question I have here is, how do you see AI impacting healthcare?
All right. Veysel, why don't you start, share your thoughts, and then I'll.
Yeah, definitely. So with the hype of LLMs, right now everyone is jumping into the wagon and then try to test different LLMs with their own data. But LLMs, as you know, if you are going to create subcohort and do some analysis, right? Ask a question like, give me all the patients who have a diabetes, also COVID symptom, etc. LLM cannot itself solve this problem, right? That's why you need to build a custom pipeline with all the tools available out there, and then how it is not about how LLM will shape the healthcare industry, but all AI will shape the industry, right? That was the question. That's why right now we see that there's still too much manual effort going on in healthcare. And then like just for extracting medical terminologies, we hire medical coders, certified medical coders, and like usually doctors, like we all know that doctors spend less time with the patients than taking notes during this. And by integrating this AI solutions into their workflow, into healthcare workflow, like ambient dictation, medical text summarization, building patient journeys, extracting entities, we automate most of the process that are already being done by human and healthcare practitioners, so that AI will probably take more space in that domain compared to the other domains, so that the healthcare professionals do their own job, which is taking care of their patients.
Yeah. And Veysel, I couldn't agree more, right, in terms of what you said. I think extending on what you just said, I think from an impact perspective, we have to look at it as not just a large language model, right? I think we have to look at it as an AI. That means that it's large language models, it's the advanced machine learning models, it's the large vision models, it's a combination of all that will impact. In my opinion, AI will impact healthcare across clinical, operational, as well as research workflows, right? And different types of AI models will play a key role, right? From a clinical context, obviously, the specialized models that are very, very well tuned on the clinical embeddings is going to play a key role, and that's what this webinar is all about, right? So you have models that are very clinically tuned. How do you really use it, for the such healthcare use cases? And then there's going to be AI used on the operational use cases in terms of how do we better plan the staffing of nurses and physicians? How do we better automate some of the administrative tasks and so on and so forth? And then there is the whole research side that deals with very different vast types of data, genomic, transcriptomics, and protein data, and the complex pathology images and other medical image types, right? So there is the rise of models that are very purpose tuned for that. And I also believe that all of this is going to evolve into agentic architectures of, there's going to be purpose specific AI agents who has ability to understand, reason, certain specific tasks, and then all of that will be brought together in a pipeline, like the way Veysel was talking about it, truly to action that from a context of healthcare.
Thank you. The next question I have here is, where can I get additional information about these models?
Okay, I can answer this. As I said, John Snow has a model hub, which means that if I just remote it, so if I go to John Snow Labs and then nlp.johnsonlabs, right? If I just go, let's go to nlp.johnsonlabs and then the model hub. So over there you will see the model hub. In the model hub, you see we have more than 100,000 models. And then I can just filter by the healthcare. We have 2,500. I can just filter by the marketplace. And for each model, I can just click on the card, and then I will be able to get all the details about these models, what it extracts, etc. And also how to use it if you are going to write from scratch, but in Snowflake, you don't need. And you can also get the benchmark. You can also see the benchmarks as well. In Snowflake Marketplace, you see all the available models provided by John Snow Labs. So I can just pick one, for example. I just pick, and then you see the model card in Snowflake Marketplace. And over there, we explain all the details about this model, what it can do, what it can extract, and then some business use cases, how to use some sample code as well. And then all the other details like how to license this, how to start using this. So we have, long story short, we have two main place to gather information about all these models. One is Snowflake Marketplace, one is John Snow Labs Model Hub, as well as the benchmarks on each venue.
Thank you. Couple more questions here. Next one is, how easy would it be to deploy any John Snow Labs model as a private endpoint or Docker-sized solution within a Snowflake inference?
Again, I can take this. So I showed like a sample notebook here, right? This notebook can be accessed in our Spark NLP workshop repo as well. So as Murali mentioned, we have two ways of doing this: deploy Dockerized solution, deploy native application. So which means that any model that you see in the marketplace, you can easily go and deploy this within your own infra by using these code blocks. Or we have a dashboard as well on the Snowflake as a Streamlit app set, so that you can start with one click. So in this notebook, I show how to deploy by coding, right? You can just specify the model name available in the Snowflake marketplace, and then run this with your own credential, and then it's going to create a UDF. From now on, you can just connect to Snowflake and then run on your data. Second way of, like the most popular way of doing this, is Snowpark notebooks, right? Because it has a native integration already. You can just go ahead and then start the app as I showed, and then run on your own data. For the private endpoint in the notebook, I also show how to deploy any solution as a private endpoint. The difference between private endpoint and the UDF is that, like the correct solution is that in private endpoint, it returns a private endpoint that you can use across everywhere in your own Snowflake infra, which means that it's just like an API endpoint served by Snowflake, which means that you just process your own data with your own infra without writing any command or any script, right? You just make a request or API call, which means it's not just Python. You can use other languages as well, because it's just one endpoint, just like an OpenAI endpoint. This is another endpoint within your own infra. Murali, do you want to add anything, maybe?
No, I think you covered it pretty much, Veysel. Thank you.
Okay, thank you.
Okay, next question is, are there any tutorials or resources to learn more about how to use healthcare NLP to customize these solutions?
Yeah, definitely. So as I said, we have the model hub to show how to use any model with your own data, right? If you go to Model Hub, John Snow Labs, you will see model cards, and then over there you will see the code samples, as well as some sample input and outputs and some benchmarks. We also have workshop repo, which means that if I go to Spark NLP workshop repo, right? Let me go to workshop. We are running, by the way, every quarter we are running 16-hour workshops, live workshops that you are more than welcome to join. Over there, we go over hundreds of different notebooks. We also have Udemy. If you go to Udemy, there's a course over there, open source and healthcare and NLP tutorials that you can just enroll and then get like 50 hours of content. But here on our healthcare and NLP repo, from John's Spark NLP workshop repo, you see all these notebooks, which are Colab notebooks, Jupyter notebooks. You see if you want to test in the different platforms, we have different notebooks as well. But long story short, yes, we have tutorials here, more than 200 notebooks. We have blog posts. You can go to Medium blog post and then see see the blog post that we are publishing every other week, because whenever we release, we publish blog posts. We have johnsonalert.com for all the other solutions that we have. For example, for the solutions, if you go to our website, you will see different solutions that we offer out of the box and different use cases. For example, we have customer use cases that you can also go to website and then see, and then click each one of them and then see how we solve their problem by using our models. And we invite speakers to join our NLP Summit as well. So we have tons of resources. If you would like to spend time or just contact us, we can provide all the resources in one place. We can even share some recording from previous trainings. So you are not short of any resource if you really want to learn our tools, and we would be more than happy to help you. This.
Thank you. And one last question for you here. Does John Snow Labs have an academic peer-reviewed papers and benchmarks to show the performance of their models?
Okay, definitely. So regarding the previous question as well, resources, right? So it's one of the resources that we have. Whenever we have a new model, a new benchmark, we are happy to write a paper and then try to compete with the other competitors. For example, for the last 5 years, we published more than 35 academic papers published on peer-reviewed journals and conferences. For example, the last one was the how to evaluate LLMs holistically. So this is one paper that we published. So if you go to peer-reviewed papers website from Johnson Lab, you will be able to see all these papers. For example, if I go to one of them that I wrote personally, like this is, for example, how to do text to SQL, and then we have the benchmarks over there compared to other text to SQL solutions. And for example, for lung test, we have another library which is called lung test. It's an open source how to evaluate machine learning or LLM under certain perturbations. So we published a paper on this, and for each model that we have, for example, the identification is published maybe in 3 different venues so far, our paper. And then over there, we show how we built the identification pipeline end to end. And if you just click on any link, archive link, you will see the detailed paper over there that we explain each step, which means that anything that we ship into Snowflake or any other environment or serve in our model app, you will be able to see a scientific proof how or details how these models work, as well as some benchmarks and some citations as well.